In this video, we're going to be looking at how we might differentiate functions of y with respect to x. Let's begin by looking at an equation like this. X squared plus y squared minus 4x plus 5y minus 8 equals 0. Now here the x's and y's are all tangled together. And the y's a y squared and a y. It would be quite difficult to rearrange this so it said y equals a function of x. We could, perhaps, given values of x, work out what values of y were, and thereby draw a graph. But nevertheless, these things are intimately connected, and differentiating something like this is going to be much harder, so it would seem, than if it just said y equals some function of x. But that's what we're going to have a look at in this video. How can we differentiate a function, an equation that looks like this, where the x's and y's are all tangled up together? We're going to use something known as the chain rule or function of a function. It's got those two names, chain rule and function of a function. I'm going to try and stick with using the name chain rule, but you may know it as function of a function. There is a video which covers this particular rule explicitly, so I'm just going to revise it. So let's take an example such as y equals 5 plus 2x to the 10th power. And let's say I want to differentiate this. Then the chain rule says that if I put u equals 5 plus 2x, then y will be equal to u to the power 10, and we can form dy by dx by doing dy by du times du by dx. And it's this that is the chain rule, or, as some of you may know it, function of a function. So this is what we've got to do. We've got to work out dy by du and work out du by dx. So I'm going to turn the page. I'm going to virtually write this out again in order to make sure that I've got the space in which to do it. So we begin with y equals 5 plus 2x to the power 10. We put u equals 5 plus 2x, and then y is equal to u to the power 10. dy by dx is given by dy by du times du by dx. And we can work out each of these two, dy by du and du by dx. So let's have a look at that. dy by du is the derivative of u to the power 10 with respect to u, which is 10u to the power 9. Remember, we multiply by the index and take 1 off the index to give us 9. And so that's 10, 5 plus 2x to the power 9, replacing the u by 5 plus 2x. And we can calculate du by dx. That's the derivative of 5 plus 2x with respect to x, and that's just 2, because the derivative of 5 is a constant, so that's 0, and the derivative of 2x is just 2. So now we know what dy by du is, it's this, and we know what du by dx is, it's this. So we can write those in 10 times 5 plus 2x to the 9 times by 2. And of course the 2 times by 10 gives us 20. And so we've used our chain rule in order to be able to differentiate this function. So let me just write our chain rule down here. Dy by dx is equal to dy by du times du by dx. Now, let's suppose that we had z, and z was a function of y. Then dz by dx would be equal to dz by dy times dy by dx, using our chain rule again. Let's take an example. Let's say that z is equal to y squared. Then dz by dx would be equal to the derivative of y squared with respect to y times dy by dx. And the derivative of y squared with respect to y is equal to 2y times dy by dx. Notice what we seem to have done is just differentiated y squared with respect to y and multiplied by dy by dx. And I'll draw attention to that again later on. For now, let's have a look at some examples. We'll begin with this one, y squared plus x cubed minus y cubed plus 6 equals 3y. We want to differentiate this with respect to x. So we're looking for the derivative of y squared with respect to x, the derivative of x cubed with respect to x, the derivative of y cubed with respect to x, the derivative of the 6 with respect to x, and the derivative of 3y with respect to x. Let's remember how we said we would do this. We said we would take the derivative of y squared with respect to y and multiply it by dy by dx. That was our chain rule. Plus, this is straightforward. You don't need to worry about this. This is the derivative of x cubed with respect to x. We know that is 3x squared. Multiply by the index and take 1 away. Minus, and here again we've got to apply our chain rule. So we've got the derivative of y cubed with respect to y times by dy by dx. Plus, now the derivative of 6, well 6 is just a constant, so we know its derivative is 0. Equals, and again we want the derivative of 3y, so our chain rule tells us this is the derivative of 3y with respect to y times dy by dx. And now we can go back and work out each of these derivatives with respect to y. So that will give us 2y dy by dx plus 3x squared minus the derivative of y cubed with respect to y is 3y squared dy by dx. We can ignore the 0, and the derivative of 3y with respect to y is 3 times dy by dx. Now, if we get together all the terms that have a dy by dx in them, then, having done that, we can sort out what dy by dx actually is. So, I'm going to gather together all the terms in dy by dx over on this side of the equation, so I can keep that 3x squared there on its own. So I'll have 3x squared equals, now here on this side I've got 3 dy by dx. I'm going to take this away from each side, so that's minus 2y dy by dx, and I'm going to add this term to both sides, plus 3y squared dy by dx. And what I can see here is that I've got a common factor of dy by dx that I can take out. So that's what we're going to do next. So we'll have 3x squared equals, bracket, and taking out that common factor of dy by dx. So let's just go back and have a look what dy by dx was multiplying. It was multiplying a 3, it was multiplying a minus 2y, and it was multiplying a plus 3y squared. So it was multiplying a 3, a minus 2y, and a plus 3y squared. So now we can get dy by dx on its own if we divide throughout by this expression. And so dy by dx is equal to 3x squared, and dividing throughout, dividing both sides by 3 minus 2y plus 3y squared. And there we've got our expression for dy by dx. That was a reasonably straightforward example. There weren't that many complications, and it followed very directly from our first look at this. So now let's look at a slightly more complicated example, one where, in fact, we've got other functions of x and y. So in this case, we'll start off with a sine y, where we've got the x's and the y's actually combined together. So we've got x squared times by y cubed minus cos x, and let's say equals 2y. And I want to be able to differentiate this with respect to x. So that's the derivative of sine y with respect to x plus the derivative of x squared y cubed with respect to x minus the derivative of cos x with respect to x equals the derivative of 2y with respect to x. Now let's remember what our function of a function rule tells us, that this is done as the derivative of sine y with respect to y times by dy by dx. This one, bit of a problem, because this is x squared times by y cubed. So it's a product. It's a u times by a v. So let me just write a little u over the top and a little v there. U is x squared and v is y cubed. So this is plus. Let's remember how we differentiate a product. We take u and we multiply it by the derivative of v. So that's the derivative of y cubed with respect to x plus v, and we multiply that by the derivative of u, which in this case is the derivative of x squared. Minus, now we can do this one, the derivative of cos x with respect to x. The derivative of cos is minus sine, so a minus and a minus makes a plus sine x equals the derivative of, and again my chain rule tells me that this is the derivative of 2y with respect to y times by dy by dx. So this has been much more complicated, but notice how it follows the standard rules that we've already got for differentiation. So now, the derivative of sine y with respect to y is just cos y dy by dx plus x squared times by, now, this will be the derivative of y cubed with respect to y times by dy by dx plus this one, y cubed times by, now, the derivative of x squared with respect to x is just 2x plus sine x, we've already done that one, equals, and here the derivative of 2y with respect to y is 2 times dy by dx. Almost done now. We've still got a little bit of differentiation in here to do, so let's do that. Cos y dy by dx plus, I think I can fairly safely remove these brackets now, x squared times 3y squared dy by dx plus 2xy cubed plus sine x equals 2 dy by dx. We're at the same stage as we were last time. We've got the differentiation done, and it's this thing dy by dx that we want. So what we've got to do is get all those terms that involve dy by dx on one side of the equation and the other terms on the other side. Now these are the two terms that don't have a dy by dx in them. So I'm going to keep them at this side. So that's 2xy cubed plus sine x. 2xy cubed plus sine x equals. Let's just go back and see what we've got. We've got a 2 dy by dx here. 2 dy by dx. And we're going to bring these two terms over to this side by taking them away from both sides. So we're going to take away cos y dy by dx on both sides, minus cos y dy by dx. And then we're going to take away the other term. This is the x squared times by 3y squared dy by dx. I'm going to write that a little bit differently when I do it. So we have minus 3x squared y squared dy by dx. Again, we see we've got a set of terms here, each with dy by dx as a common factor. 2x y cubed plus sine x is equal to, let's take out this common factor of dy by dx. Well, it's multiplying 2, so we've got a 2 there. It's multiplying minus cos y, so we've got a minus cos y there, and it's multiplying minus 3x squared y squared. So we're minus 3x squared y squared. And now finally, we can get dy by dx on its own, because we can divide both sides of the equation by what's in this bracket. So we'll have 2xy cubed plus sine x all over 2 minus cos y minus 3x squared y squared. And there's our dy by dx. Now, let's just look back at this one. Look at all this complicated differentiation that we had here. Now, I went through it slowly and carefully, but when we're doing calculations on our own, we might make slips. It would be helpful if we could automate some of this process, so that instead of writing down the derivative of sine y with respect to x is and going through the chain rule, we went automatically to all we need to do is differentiate sine y with respect to y, that's cos y, and multiply by dy by dx. So we automate. We would miss out at least these two lines and go direct from there to there. Similarly, the derivative of 2y with respect to x would be the derivative of 2y with respect to y, 2, times dy by dx. And so we go direct from there to there. So let's have a look at that in another example. So we'll take y squared plus x cubed minus xy plus cos y equals 0. This time we're going to go direct to the differentiation. We're not going to go via the chain rule. We're going to use it, of course, but we aren't going to write it down. So we want to differentiate this with respect to x. So the first term is y squared. So we know that to differentiate y squared with respect to x, we differentiate this with respect to y, that's 2y, and we multiply by dy by dx. Now we want the derivative of x cubed with respect to x, so that's 3x squared. Minus, now I am going to write this down in full because it's the derivative of xy with respect to x. It's a product again. It's x times by y. Plus the derivative of cos y with respect to x, which we do as the derivative of cos y with respect to y, that's minus sine y times dy by dx. And the derivative of 0 is just 0. So let's get these two terms together, because they've both got a dy by dx. So I have 2y minus sine y times dy by dx plus 3x squared minus, now this is a product. It is a u times by a v. So we want u times the derivative of y with respect to x, which is just dy by dx, plus v, which is y, times the derivative of x, which is just 1, equals 0. So we see here that we've got another term now involving dy by dx. It's minus x. So we can put that in the bracket. So we can have 2y minus sine y minus x dy by dx plus 3x squared, and then minus this term here, minus y equals 0. If we take this over to the other side, in other words, we take this away from both sides and add that to both sides, you'll have 2y minus sine y minus x times dy by dx is equal to, adding this one to both sides, y, taking this one away from both sides, we get that. And now, it's clear how we would finish this off. We would take this factor here and divide both sides by it. So we'd get dy by dx was equal to, just go back, we've got y minus 3x squared to go in the numerator on the top, and this factor to go on the bottom in the denominator. 2y minus sine y minus x. And there we have our derivative. Let's just take one more example. Y cubed minus x sine y plus y squared over x equals 8. Again, all the x's and y's bundled up together. If possible, we want to be able to do this directly. We want to be able to differentiate it straight away without going through the chain rule. So the derivative of y cubed with respect to y times by dy by dx. So that's 3y squared times dy by dx minus, we want the derivative of this. This is a product, so let's see if we can do it all in one go again. We want x times the derivative of sine y with respect to x. That's x times cos y dy by dx. And now we want sine y times the derivative of x. So that's sine y, and the derivative of x is just 1. This one's a bit trickier. This is a quotient, y squared over x. So we want plus. Now let's remember what we do with a quotient. It's v, which is on the bottom, that's x, times the derivative of what's on the top, the derivative of y squared with respect to x, which is the derivative of y squared with respect to y, 2y times dy by dx, minus y squared times the derivative of v, which in this case is just x, all over v squared, which is x squared, equals 0. Now this needs a little bit of tidying up. We've got a denominator here that we can probably multiply up by. So let's do that and do some tidying on the way. So this will be 3x squared y squared dy by dx minus x cubed cos y dy by dx minus x squared sine y plus 2xy dy by dx minus y squared equals 0. So I've multiplied throughout by this x squared. So the x squared has appeared there, multiplying that. It's appeared there inside that x cubed, multiplying that. It's appeared there, multiplying the sine y. And it's gone from here because we've multiplied by it. So multiplying and dividing by it, we're in effect leaving this unchanged. Now let's get together all the terms in dy by dx. So we have dy by dx times this term, 3x squared y squared, this term, minus x cubed cos y, this term, plus 2xy. And here I've got minus x squared sine y. Well, I think I want to add that to the other side, so that's plus x squared sine y. And here I've got minus y squared. Again, I think I want to add that to both sides, so I get plus y squared over there. And now dy by dx is equal to x squared sine y plus y squared in the numerator and dividing by this expression as the denominator. 3x squared y squared minus x cubed cos y plus 2xy. Notice how much shorter automating that differentiation has made what's quite a complicated problem. And that's something you want to work at, trying to automate your differentiation so you don't have to go through the rules and write them down every time.